It. What is plasma? Plasma is the often forgotten part of the blood. White blood cells, red blood cells, and platelets are important to body function, but plasma also plays a key role. This fluid carries the blood components throughout the blood. Facts about plasma. Plasma is the largest part of your body. It makes up more than half, about 55% of its overall content. When separated from the rest of the blood, plasma is a light yellow liquid. Plasma carries water, salts, and enzymes. The main role of plasma is to take nutrients, hormones, and proteins to the parts of the body that need it. Cells also put their waste products into the plasma. The plasma then helps remove this waste from the body. Blood plasma also carries all parts of the blood through your circulatory system. How does plasma keep you healthy? Plasma is a critical part of the treatment for many serious health problems. This is why there are blood drives asking people to donate blood plasma. Although with water, salt, enzymes, plasma also contains important components. These include antibodies, clotting factors, proteins, albumin, and fibrinogen. When you donate blood, healthcare providers can separate these vital parts from your plasma. These parts can then be concentrated into various products. These products are then used as treatments that can help save the lives of people suffering from burns, shock, trauma, and other medical emergencies. The proteins and antibodies in plasma are also used in therapies for rare chronic conditions. These include autoimmune disorders and hemophilia. People with these conditions can live long and productive lives because of the treatments. In fact, some health organizations call plasma the gift of life. Donating plasma. If you want to donate plasma to help others in need, you will go through a screening process. This is to make sure your blood is healthy and safe. If you qualify as a plasma donor, you'll spend about an hour and a half at the clinic on every follow up visit. During the actual blood donation process, your blood is drawn through a needle placed in a vein in one arm. A special machine separates the plasma and often the platelets from your blood sample. This process is called plasmapheresis. The remaining red blood cells and other blood cells components are then returned to your body along with a little saline solution. Type AB plasma can be given to people of all blood types. Because type AB blood is rare in the US, this plasma usually is in short supply. At non commercial donation sites, people can donate plasma every 28 days, up to 13 times a year. Plasma in that institute. Plasma is superheated matter, so hot that the electrons are ripped away from the atoms, forming an ionized gas. It comprises over 99% of the visible universe. In the night sky, plasma glows in the form of stars, nebulas, and even the auroras that sometimes ripple about the north and south poles. That branch of lightning that cracks the sky is plasma. So are the neon signs along our city streets, and so is our sun, the star that makes life on Earth possible. Plasma is often called the fourth state of matter, along with solid, liquid, and gas. Just as the liquid will boil, changing into a gas when energy is added, heating a gas will form a plasma and a soup of positively charged particles and negatively charged particles. Because so much of the universe is made of plasma, its behavior and properties are of intense interest to scientists in many disciplines. Importantly, at the temperatures required for the goal of practical fusion energy, all matter is in the form of plasma. Researchers have used the properties of plasma as a charged gas to confine it with magnetic fields and to heat it to temperatures hotter than the core of the sun. Other researchers pursue plasmas for making computer chips, rocket propulsion, cleaning the environment, destroying biological hazards, healing wounds, and other exciting applications. Future of fusion. The fundamental features of fusion, inexhaustible fuel, and large power density would allow it to provide carbon free energy at a scale needed to address climate change, making clean, safe, and economical fusion energy available to our society is a grand challenge of 21st century science and engineering. There is no known science stopping us from developing fusion energy. In fact, the fundamental conditions needed to make fusion, such as achieving temperatures of 100 million degrees, have mostly been achieved, including in laboratories at MIT. Nonetheless, many people wonder if fusion will be available in a timely manner since it has been long promised but slow to become reality. Fusion has been delayed because its science was more complex than first imagined and due to the large sizes of experimental facilities needed to explore fusion.